This section will be discussing relative velocity. And while the AP exam will almost never ask about relative velocity directly, it does come up implicitly in some problems. In fact, we saw it before in the problem where we were seeing a screw drop from an elevator as the elevator rose from the ground. And the key to relative velocity is the idea of a reference frame. This is the physical object to which the origin is attached. And the reason it's important is that an object's velocity depends on the reference frame. Two different reference frames may measure a different velocity for the same object. Now, we will usually attach our reference frame to the Earth, and if you look back at the elevator problem with the screw falling, that's what we did there. But it is possible to attach the reference frame to other objects that are moving relative to the Earth, say a truck that's moving at a constant speed, and we will do this briefly in Chapter 11. If two reference frames are moving at a constant velocity to each other, though, then an object's acceleration will be the same in both, which is to say they will measure the same acceleration for the same object. So while they might disagree on the position of the object relative to their origin, and they might disagree on the velocities of that object, they will agree on the object's acceleration. And the key to all this is that in the end, we should be able to get the same physical answer in both situations. We just may have to translate between the two reference frames. So let's go ahead and look at that in this example here. In this case, we have a boat which is traveling directly across a river, so it's pointing to the other shore, when it encounters a current of 2 meters per second downstream. And what we're going to be looking at in this example is the perspective relative to somebody standing on a shore and relative to someone sitting in a canoe that's drifting down the river. So let me go ahead and draw a picture here. I'll go ahead and draw the sides of the river and maybe a little inlet for the boat to leave from. And then I'll go ahead and draw the current going down. And so this boat is coming out of this inlet at 5 meters per second, and it continues to drive at 5 meters per second as it encounters this current. Now I'll go ahead and draw my origin relative to somebody standing on the shore, and so let me go ahead and illustrate that here. In this case, I'll draw the X direction to point towards the right, and the Y direction to point upstream, which is up in this picture. And so now let's go ahead and look at part A. What is the speed of the boat relative to this person on the shore? Well, I can start to write down the relevant information, and I won't write down all the kinematic variables. There is no acceleration in this case because all the velocities are constant. And so the velocity in the X direction is 5 meters per second because the boat is driving directly to the opposite shore. And the velocity in the Y direction is -2 because it's drifting downwards with the current at a rate of -2 meters per second. When I find the speed by plugging this into the Pythagorean theorem, what I get is that the person on the shore will measure the speed of this boat as 5.4 meters per second. What about the perspective of a canoe drifting down the river? Well, I'll try and draw that in green. And so here's my canoe, and it still measures the X direction to the right and the Y direction to be upstream. But the point is as time goes on, this canoe drifts farther and farther downstream, and with it, so does our origin. So how does this affect the calculation of the speed of the boat? Well, its velocity in the X direction is still going to be measured as 5 meters per second. This canoe has no motion in the X direction, and so it perceives the X velocity to be 5, just like the person standing on the shore. On the other hand, it's drifting down the river as well, and so it perceives the Y velocity to be 0 meters per second because the boat and the canoe are going down the river at the same speed, and so they don't perceive any motion in that direction. This gives that the person in the canoe will perceive the boat to be moving at a speed of 5 meters per second. So as you can see, they disagree on the speed that the person is traveling. But here's the point, is that if we ask an actually real-world question, like how long does it take for the boat to reach the other side, both are going to agree on that. In this case, the question is, what is t when x equals 50 meters? And they're both going to agree because they realize that it needs to travel 50 meters and that its speed is 5 meters per second in that direction. And so they'll both agree that the boat will take 10 seconds to reach the other side. Now, while that was rather straightforward, the next part D, how far downstream is the boat when it reaches the other side, is a little bit different. In this case, let's go ahead and look at it from the perspective of the person on the shore. This person is asking what is y when t equals 10 seconds. And so in this case, y is equal to -2, the speed it's drifting down the river, times 10, and so y is equal to -20 meters. And so this person says, oh, the boat is 20 meters downstream when it reaches the other shore. That should be rather straightforward. What's different is if we consider the perspective of the canoe. In this case, the canoe perceives that there is no y velocity for this boat. And so where is it located after 10 seconds? Well, it says y is equal to 0. But the point is we haven't answered the question. If the canoe is going to answer this question, it's going to say, well, y is equal to 0, but I drifted 20 meters downstream, and so it drifted with me, and so therefore it's also 20 meters downstream. And so you can see that from both perspectives we end up at the same answer, just for slightly different reasons. And so while we won't use relative velocity very often, I think you can see how important it is to give a little bit of thought to the reference frame, which is to say the physical object to which you decide to attach your origin.